I will be starting my presentation. Great, so everyone can see the slides, yeah? Okay, I'll take the slides over there.
Yes.
Yes, I can see it.
Okay, so what are we going to learn in this class? Well, I'm going to say networking is like pretty confusing. So we're going to first try to understand like the basics of networking, like how does it work? And also what is the IPv4? So first, we should review some vocab. And the vocab I will probably review with you guys would be host, IP address, switch, data, and routers, and more vocabulary as we go along in class. So a host, that is a hardware device, and this can connect to a network. Hosts are also known for individual computers or hosts. Hosts are basically just computers. The IP address. The IP address is basically a label that is assigned to devices in a network. And it's a name.
I'm sorry. I'm sorry. Okay, Gordon, it's June here. I'm not sure it's my problem or other people's all have problem. I barely can hear you. Maybe because your microphone is not placed right, or can you, anybody can hear that clearly? Hello.
Mine is also like very like fuzzy and glitchy.
Okay, yeah, Gordon, try to move your microphone a little bit closer.
Is this better? Well, I can't hear anyone. I don't know if no one's talking.
It's still really fuzzy.
Uh,
Is this any better?
Yes.
Yeah.
Way better.
Okay then. So as I was saying, wait, you guys know what hosts are? Okay, hosts are basically computers and they can connect to a network and they're hardware devices. An IP address is a label assigned to devices in a network. And note that IP addresses are going to be unique. So a device or two devices cannot share the same IP address. And you can basically think of them as a name. A switch. This is a hardware networking device, and this device will connect hosts to a network. So it's going to connect computers together. Data. Data and networking can be like a lot of things. This could be text messages or statistics you want to send to a different host. And routers. Routers are another hardware networking device, and they basically connect different networks together. And note this router on the bottom left is the router that we'll be talking about. A home router, which is the one on the bottom right. They are different from the routers that I will be talking about because home routers are built to be very convenient and easy to use. And basically, a home router is just a bunch of good features stuffed in one machine. Think about it that way. So now you got all that vocab out of the way, so we're gonna bring in an analogy. So a network, we can also think of it as a huge airport system. So we got the terminals, which is the main area, and there are multiple other terminals, and of course you can use airplanes to go to any terminal. And there are also the waiting rooms, and basically inside these waiting rooms you got passengers. So if a passenger in, let's say, waiting room 1 wants to go from waiting room 1 in the PDX terminal to the waiting room 1 in the SFO terminal, then this person would go to the PDX terminal, fly over here, and then go to the waiting room number 1. So if we look at this in a like networking perspective, then these terminals would be routers because routers are all connected to each other. And these waiting rooms would be like switches, and a group like these switches are basically connecting all these hosts or computers, which in this analogy, the hosts are going to be the passengers. And an LAN basically means a local area network. So this group right here that's getting connected by this switch is considered or we're going to just call it local area network 1. And then this switch here is going to be local area network 2. And let's just say this computer over here in local area network 1 wants to talk to a computer in local area network 2 in router 3. And basically what this computer would do, it would go to the switch, which the router, yeah, that will go to the router, go to another router or router 3, and then that will go to the switch in LAN 2 and then go to the computer. So here is basically a table that's mapping out your vocab words. So let's pretend like in the waiting room, a passenger would be a host in the network view. And we would call the waiting room as the LAN or local area network. Okay, the passenger's name, that's just going to be the host's IP address. And again, it has to be unique. So each passenger has different names. Okay, the room itself, we're just gonna call it the switch because the switch is the one that's like connecting all these hosts together. The messages, or let's say someone like passenger 1 wants to talk to passenger 2, the message is going to be data. And basically data has like different names, which we'll go over later in like the different layers. So this is what we call a switch layer. So we call it data and the switch layer frames. Okay, and the waiting room number, or you know how in airplanes where each waiting room has like a different number, you can have like A1 or B3 or whatever. Yes, this waiting room number is going to be called the network IP address. So it is basically an IP address for the network. And then the loudspeaker, where sometimes the airplane, I mean, like the people are announcing things such as like, everyone in this waiting room, we are now boarding such and such plane. That will be called the broadcasting IP, which is basically if you want to send a message to every single like host in a network, then you would want to send that to the broadcasting IP. So it broadcasts it everywhere. And then finally, like the exit to the terminal. That is basically the gateway IP. Just think about it as a door, and then you name the door. So then if we look at it from like the terminal view, then the entrance to the waiting rooms, we're going to call those router ports because the terminal is a router and basically the ports just kind of connect the router with the switches and such. Passengers, they turn into data, and it's kind of weird, but this analogy is like not perfect, I guess. So don't really overthink it too much. But basically, we call the data in routers, in the router layer, a package. Okay, and then finally, the flight info display board, which is like those huge boards that are just giving you the statuses of airplanes, like such airplane to San Francisco is landing or is leaving or is going to be delayed. This is just going to be called the routing table because the routing table is literally just a huge list filled with routers. So this is the OSI model, or open system interconnected, but you don't really need to remember that. And the OSI is basically a set of rules on how hosts communicate to each other. And this looks very complicated, and it kind of is. So we're just gonna like talk about only these 2 layers, networking and data link, which are also highlighted in red. And so the network layer is also the router layer. So when data is going through the router, then as you can see here, it is called a packet. And then the data link layer is also the switch layer. And we already read this, and the data that's going through the switch layer will be called frames. And of course, physical layer, you got bits, but yeah. So binary. You might have noticed in the physical layer, in the bits were ones and zeros, and that is something called binary. So binary, it's a different way of writing numbers. You can basically use any number we have that we know of, and you can write it out in binary. And a lot of computers use binary instead of the numbers we use for reasons. And a very easy and simple method to turn a number binary is to just divide a number by 2 and take the remainder until you have reached the result of 0. I mean, it's basically, let's get the example of 14. So 14 divided by 2, you get 7. And also you get a remainder of 0. 7 divided by 2, result 3, remainder 1. 3 over 2, result 1, remainder 1. And then 1 over 2 is result 0, remainder 1. So because we reached the result of 0, we want to stop. And then we take the remainders by looking at the bottom up to the top. And then that's your binary number. So 14 in binary is 1110. And basically, that's just an easy way to convert decimal to binary. If you really want to go more into binary and like how it actually works, you can search it up on Google. And also there's going to be an important function that you should know, and that is the AND function. And the AND function is basically saying you got 2 inputs and an output. So if both of your inputs, by the way, are going to be zeros or ones, 0 or 1. So if both of your inputs are equivalent to 1, then you will output 1. But if one of them is 0 or if both of them are 0, then you're going to output 0. So that is what the AND function is. So anyone can see their anyways. So you can see your own IP. It's not that hard. Just I'm not sure if you can see this, but if you open command prompt, you can type in ipconfig, and it should give you like a huge list of information. And in that list, you will see IPv4 address with your address, and then your subnet mask. And we will review what a subnet mask is later. Okay. Oh, whoops. And subnet mask, basically, if you use the AND function and you grab your IPv4 address and then put it with the AND function with the subnet mask, you will get your network IP, which again is the waiting room IP or the name of the waiting room, like A1 or B3. And this waiting room IP also determines the amount of available IPs you have, and we will go over that later. Okay, so here we got a spreadsheet, and this spreadsheet basically calculates the total amount of IPs, so a lot of other things. So over on the top that's highlighted in orange, you can see that you are supposed to input your IP address, and once you input it, you can also have your mask here. And in this example, our mask will be 255.255.255.0. And basically, we use the AND function. So at the very bottom of this screenshot, you will notice that there's a bunch of binary numbers. So these binary numbers are actually just, this top row of binary numbers will be your IP address, but all these numbers will be converted into binary. And then this bottom or the second row is just your mask that's converted into binary. And then over here, we do the AND function. So these two are 1, then you put 1, and these two are also 1, you put 1. One of them are 0, you put 0, and so on and so forth. You just do AND function everywhere. And that will be your network name in binary. And you can convert that to decimal, and you will get this, which is 192.168.0.0. So the first available IP will be 192.168.0 and 1. The reason why your first available IP is not 192.168.0.0 is because, again, IPs are unique. So because you have already named your network 192.168.0.0, you cannot name anything else your network name. Also, broadcasting IP. Didn't really mention this before, but broadcasting IP is normally going to be the last IP you have. So in this case, our last IP will be 255, which means the last available IP we have will be 254 because we can't use 255 anymore because it already is the broadcast IP. Yeah, any questions? No questions? It's a bit confusing, so you could ask anything if you're confused at all.
How does the like and thing work?
Okay, so you have converted your numbers to binary, so your numbers will only be ones and zeros. So the AND function, let's just think of 1 as true and 0 as false. So the AND is trying to see if both of your values are true. So you're giving it 2 inputs and it's going to output one number. So if both, or if input 1 and input 2 is equal to true, then your output will be true. But if either one of them are false, or both of them are false, then you will also input false. Does that make sense?
Do you ever use the last available IP?
I mean, you can basically assign these IPs, whatever, like your hosts, because when you add a new host, you're going to want to assign an IP. So this is basically like, you can assign these IPs to whatever you want. But normally, the 0 at the end is your network name, and then your last, like your final available IP will be always reserved for your broadcast.
Hey, June here. Hey, Gordon. Give me like a chance to spend a little bit more time on the AND function. Can you click that practice? Yeah, click that. Yeah, that's right. Can you move to the right a little bit? Yes. Yeah. Okay. Good. So now, whoever acting at the AND function, so you can think about A is I straight, right? B is like column row 4, right? So all combination of they can either 0 or 1, right? All combination is a 0 0 1 0 1 1, right? So the AND function, as exactly Gordon said, is if both of them are 1, the output is 1. Say the M5. Can you highlight M5 cell? Yeah, yeah. So only both of them are 1. The output A and B is true, is 1. All other case is 0. Okay, so now go back to the main page. Okay, whatever is that is the official definition of the AND function. This is correct. But another way to think about it, you can think about AND is a filter. So if you look at the first row, is the IP, right? It's the IP address in format of binary. The second row is the mask. You can think about a filter. The filter means if it's 1, you're gonna pass through whatever that IP to the bottom, right? So for example, so for the first section, it's a 1100000, and your mask is 01. That means the AND operation, after AND operation, the operation. By the way, the result is at the bottom row. You're gonna be exactly the same as the first row. Did you notice that? So you can think about filter. So you think about 1 is a pass, and the 0 is non-pass. What is 0? Was set to 0. You can think about this way. I think looking this way is at least for me, it's easier to remember this. So this is my 2 cents of the AND function. I mean, especially for the network masking. By the way, if you guys want to participate in the cybersecurity thing, you're gonna do a lot of network configuration. The mask and the mask IP of a host and the network is essential. You need to have a very good understanding of this. You know, be a part of you, and that way you can solve the problem very quickly. This is the way we did it. We kind of building a spreadsheet and showing everything, one spreadsheet, and which is, I think, is efficient. There's a lot of other way. If you search the internet, there's kind of like a lookup table. Sometimes manually calculate stuff like that. But building a spreadsheet, I think, is very efficient on that, and you quickly understand what is that. Yeah, that's my 2 cents of an end on the mask.
Okay, right. And another thing I forgot to mention about your mask is your mask, as you guys notice the example provided here, your mask has 24 ones in a row and then 8 zeros. If you were wondering if a mask can be like 1, 1, 0, 0, 1, and like a bunch of other random numbers, the answer is no, because a mask has to have it has to have a consecutive number, or it has to have a consecutive string of ones followed by zeros. So you can't have any interruptions. And because this is a thing, if normally like we would just have 255, 255, 2550, so that would result in 24 ones plus 8 zeros. So we would call this a /24 because there are 24 ones. But if our mask was like 255, 255, 255, 128, that will result in 25 ones. So we would call that /25. And also, if you didn't notice, this is just the binary version of these numbers over here. So does anyone else have any other questions relating to this?
I want to add in somebody asking about the last IP available. You can think about this way. So in this case, you can say the mask is 255.255.0. That means it's the all last 8 bits is a total number of IP you can have, which is 254 if you calculate, which is 2 power of 7, I think, 7 or 8. 7, I think it's 7. So you always have 2 reserved IP. Reserved means you cannot use it. The first reserved is the network name. It's always be the first IP. It's 0 here. The last reserved is 255. It's the very last one. This is 2 reserved. Anything else you can use, right? I mean, another one you always need it in most of the case is you want a gateway. In our example, is our in the waiting room, you need to access to either to terminal or to other waiting room. If you look at your home router, there should be something called, hey, Gordon, can you go back to the previous page? The one with a command line. No, the one have a command IP config.
Oh.
Yes.
I have a
Okay.
question. For the last one, does it always have to be 255 or can it be something different?
That's depend. Okay, Gordon, why don't you open the spreadsheet and demonstrate people what will happen if you put the mask to the spreadsheet. Yeah, this is hard coded. This screenshot is a 255. Yeah. This is the 0, right? If the mask is 0, why don't you try this one is the 128? See what happens and expand to people.
If we change, so this is all going to be 255, 255, 255. If we change this one to 128, this will add a 1 over here, and that would be /25. And because we're using the AND function, well, I mean, it doesn't really change anything for this case. I mean, your network name won't change at least, because this will be 0. But because this is all, because you like kind of, you used up a bit in a sense for this 128, that will make your available IPs also decrease by 128. And then obviously there's also 2 reserved for your first available your network, and then you're broadcasting. So it will reduce your amount of IP. Well, yeah, basically, yeah, it's going to reduce the amount of available IP addresses. But you could set this to whatever, as long as it's a consecutive string of ones followed by zeros.
Hey, Gordon, make a F6 cell much larger font. People can notice the difference. Make it like, yeah, make it bigger. No. I mean the size of the. Make it like right now it's the size of 10, right? Make it size of like, yeah, 12. Yeah. Notice this trend. Change this 128 to 0. So, let people to know what's the difference.
Yeah, so as I mentioned, because you kind of use like a bit, it's going to subtract 128 from your available amount of IPs, which, yeah, it gives you less amount of IPs you can use.
Okay, always also make F12 bigger. Yes. Okay, so now right now, the F12 is O0, right? That means OA bit. Remember, this is a binary. So each bit has a power of 2 only. So if O0 means OA bits are available for your whole network, the number host of a network. If you compute that, it's equivalent to 256. Now change that, the yellow cell, to 128. So did you notice that the largest bits become 1, right? That means your network only have an open slot of 7 bits. So now because it's binary, so you're cut in half. So your available IP becomes half of 256. You can think of how big that waiting room means, how many passengers you can have in that waiting room. In more realistic situation, you can think of each waiting room is a class, or in company is a department. How many people or how many computer that network maximum can have, right? You need to allocate that, because it's kind of a resource. You do not want to put an infinite number. You want to put some reasonable number there. So this network right now can host maximum 228 minus 2 host, because there's a 2 IP is reserved. One is, again, is the network name. You can represent into the waiting room number. The second one is called broadcasting IP, which is in the Gordon's case, in an exact analogy, is loudspeaker. These 2 IP always reserved. Reserved means you cannot use. It's already, in a pre-assigned. Yeah, you want to play with this a lot. It's always need a lot of practice. I mean, to make sense of yourself. But whatever. But what I'm trying to say is using this spreadsheet is help us. I mean, in terms of solving the problem or understanding.
Okay, so anyone else have any questions? No questions? Okay.
Or maybe we can talk about what you guys expecting for next 2 classes. We have our plan. Me and Gordon, and prepare for those. The first one we prepare for, hopefully make people have some sense of what the network is. And next one we're planning to do some packet tracer hands-on experience, to building up something and set it up something. That's our plan. But what do you guys Anything you want us to talk in next 2 minutes, basically. Some feedback.
Okay, if no one wants to say anything, I got a Kahoot prepared. So I really hope you guys pay attention, because yeah, you won't get first place if you didn't pay attention. There is no prize, but you can feel good about yourself if you get first place. So let me just pull it up real quick. Okay, so I'm guessing that Kahoot isn't very popular among you guys because there are 18 participants and there's only 6 people joining the Kahoot. So if anyone's in the process of trying to join the Kahoot, like make a noise or something, so time isn't wasted. Okay, not hearing any noise, so I guess we're just gonna get started with 6 people. What is an example of a host? Okay, the answer is the computer. A router and a switch are not hosts. A host is something that can like connect to the network, such as a computer or a phone. So good job to Scott, Anya, someone, EXP20, and Garfield. What is 17 in binary? Okay, great. You guys all got this one correct. I don't know if you use my method or you use your own method, but you got it correct. So, okay, looks like EXP20 has now risen to first place. Someone is second place. Scott is now third place. Anya, Garfield are fourth and fifth. True or false? 1 and 0 equals to 1. Okay, the answer is false because the AND function is comparing if both of your values are equivalent to 1. And because 0 is not 1, you will not get 1 as a result. Oh, someone and Scott have risen up the leaderboard. How do you find your network name? Okay, the answer was to use the AND function with your subnet mask and your IP address. So if you use your AND function with subnet mask and IP address, you will get your network name. By the way, if you use ipconfig, that's where you find your subnet and IP address. Okay, Scott is now first place and Anya is third, moved up to third place, and someone is now second place. I call that the switch level.
Yeah, Kahoot.
Okay, the answer is frames. For those of you who chose packets, packet is what we call data at the router level. But yeah, congratulations to anyone who picked frames. Someone and Anya have moved up. What does a switch do? Okay, the answer is 3. The switch will connect hosts together. Routers can connect with other routers by themselves. They do not need a switch to do that. And blue, a switch sounds like an on and off thing, but it isn't. It literally just connects hosts together. So keep that in mind. Also, someone chose green. Questionable choice, but oh well. Okay, Anya and Scott have moved up, and Garfield as well. True or false? IP addresses are unique. Okay, good. Everyone got this one correct. IP addresses are in fact unique. You cannot have two devices with the same IP address. And the network name also cannot be the same as a host's IP. Okay, the leaderboard has remained unchanged. Looks like Anya is probably going to win this one. What is a routing table? Okay, great. Everyone chose the correct answer. A routing table is a table that is a list of routers. Leaderboard still remains unchanged. Okay, what is the broadcast IP for? Okay, everyone chose the correct one. For anyone who's thinking about blue, the first available IP address is the networking. Broadcast is always the last. Okay, leaderboard remains unchanged, and I don't think the score's gonna change because the next question's redundant. The answer was bagel. Bagel was not an option. So I guess anyone who noticed that, congratulations. Okay, third place with 9 out of 10, we have someone. Second place with also 9 out of 10, we got Scott. Okay, and then first place with 10 out of 10 is Anya, with fourth and fifth place being Garfield and EXP20. Congratulations. Okay, so difficult questions. I guess no one really knows what a switch does. But yeah, data is frames at the switch level, and a switch is connecting hosts together. So I guess that's basically it. Bit early, 15 minutes, but you guys are free to go.
Oh, hold on. I have something to say. So again, about next class, we're planning to do some hand-on demonstration of the building up the network. And we are planning to use some software called a packet tracer. If you participate the cybersecurity thing last year, you will know what it is. It's kind of like a simulation tool. It can, besides that education purpose, is really used by professional. If you already participate, talk to your coach. There should be somewhere to download the software. I highly recommend you to install that before the next class. You can maybe do the same thing as Gordon to demonstrate. Because next class, well, we're planning to heavily focus on that. If you not, I think that software is free. Just Google search, try to install it. Let me know if there's any problem. Maybe they can help. But I'm just saying, if you want to, again, highly recommend you do make the software ready, and you can do those things. It's a very fun software. You can build in lots of stuff and run in the real network thing, stuff like that. Yeah, that's what I have.
Okay, now you guys can go.
Thank you, Gordon.
Thank you.
Yeah, bye.
Thanks.